I will present for you our framework entitled Background Subtraction and Logical Relationship for Moving Object Detection in Urban Traffic Video. This presentation is divided into the following parts: Introduction, Mixture of Gaussian method, Approximate Median method, Successive frame difference based on XOR operation, experimental results, and finally conclusion. Moving object detection is a fundamental technology for video applications, such as traffic monitoring, human motion capture, and video surveillance. A common approach is to perform background subtraction, which identifies moving objects from the portion of a video frame that differs significantly from a background model. For a given image, mostly likely to be video frame, we want to identify the foreground objects in that image. So, to apply the background subtraction technique, we follow these steps. At first, we estimate the background for time t. Then, subtract the estimated background from the input frame. And apply threshold th to the absolute difference to get the foreground mask. But the question here is, how can we estimate the background? Therefore, several methods have been proposed to estimate the background model from the temporal sequence of frames, each with different strengths and weaknesses in terms of performance and computational requirements. In fact, we choose to implement methods of varying complexity as follows: high complexity using the mixture of Gaussian method, then medium complexity using the approximate median method, then low complexity using the proposed 6 frame difference based on XOR operation. Number 1, the mixture of Gaussian method. This method was proposed to model the background by mixture of K-Gaussian distributions when it's blurred and not completely static but contains small motions such as swing 3. For each incoming frame, the value observed for each pixel is compared to the current corresponding distribution to decide whether the pixel belongs to the background or to the foreground as follows. The threshold t is set proportional to the estimate variation in order to ensure a pixel is classified as being from the foreground only when it's outside the normally observed level of variance. Second, the approximate median filter method. In this method, the estimated value of each pixel in the background model is incremented by value v if the current observation is greater than the previous estimate, and decremented by value v if it's less, as follows, where bt is the background model and ft is the current frame. This approach classifies pixels as foregrounds by subtracting the current image from the background model, then applying the thresholding as follows. The classical successive frame differencing method implies the computation of the difference between two successive frames in the video scene and using this difference to detect the object. The difference pixel to pixel between two successive frames allows relating the temporal chains in the video. The temporal chains due to movements of the object give rise to 3 regions. Number 1, the sliding region, intersection of the regions covered by the object time t and time -1. Second, the covered region covered by the object only at time t. And number 3, the ecoregion, ghost region occupied by the object only at time t -1. The third region doesn't belong to the object and should not be taken into account and considered as fall detection. Therefore, in order to obtain a correct detection, update the background periodically and keep only the sliding zone with the covered zone. We propose to reconstruct the object by applying the logical XOR operation as stated in the following figure. For the algorithm of the proposed method, we have the following parts. At first, we select the first frame f1 at time t without any object. Then we compute the difference between the frames f1 and f2, then apply the thresholding to get the binary map m1 as follows. Third, we compute the difference between f2 and f3, then apply the thresholding to get the binary map m2. Fourth, we calculate the XOR of m1 and m2 to reconstruct the object in the new binary map by this relation. 5. We compute the difference between F2 and F3, then apply the thresholding to get the binary map M3 by frames F3 and F4 by this relation. 6. We calculate the XOR of M3 and S1 to reconstruct the object in S2. We repeat step 5, then step 6 until the ultimate frame. Now the object is defined only by the sliding region and the covered region. The resulting foreground masks show that the mixture of Gaussian method gives good results as depicted in these figures, followed by the approximate median filter method as shown in this figure, followed by the modified successive frame difference based on XOR method, which could remove the ghost as can be seen from these figures. All these background subtraction methods share the following drawbacks. First, the foreground masks are generally noisy, with unwanted and isolated foreground pixels. Second, in some cases they cannot prevent the false foreground detection caused by the non-static object, like the snow grains. Third, some parts of the object may have the same contrast as the background, which causes an overlap between the background and the object. This resemblance leads those models to detect the corresponding pixels as non-foreground. Fourth, they cannot distinguish between two objects that are close to each other. Fifth, they produce foregrounds with internal holes and small gaps or disconnected foreground regions. In this work, we have handled the problem of moving object change detection. Our technique makes use of the change content of both background modeling and background detection. The logic relationship is used to distinguish the ordinary moving object and ghost region with respect to a background frame. This technique is tested on urban traffic video sequences and compared to the mixture of Gaussian and approximate median filtering. While the mixture of Gaussian produces the best results with high complexity, approximate median filter gives good performance with median complexity, and the proposed method based on XOR offers a simple alternative with competitive performance. And thank you for your attention.